Bismillahirrahmanirrahim. Assalamu alaikum dear students. I am Arif and I welcome you all in today's session. Well, to access a notebook for today's session, you can access the course page of my personal website arif.me. You can click the appropriate link under this lecture resource column over here to open the notebook and view it in NB viewer and run it online in Binder. The other way is to download the notebook from the course GitHub repository arif.me, and all the notebooks for this course are housed in the public data science repository. This is the Jupyter notebook dashboard running locally on my machine at port 8888, and here is the notebook for lecture number 3.11 of the third module, Python Programming for Data Scientists, for the course titled Tools and Techniques for Data Science. Well, my dear students, this is the third session on Pandas. In the last session, we talked about the Pandas data structure, that is series. And today we are going to talk about the second data structure of Pandas, and that is data frame. For details, you can visit this website to read the documentation, official documentation. Well, today we will start with the anatomy of the data frame. We will learn how we can create data frame from a two-dimensional NumPy array, to create a data frame from our dictionary of Python list, and to create a data frame from a dictionary of Pandas series as well. We will have a discussion about some important attributes of a data frame, and in the end we will have a bonus part. Okay, so right now the Pandas version on my machine is 1.3.4. Okay, so let's have a quick discussion on the anatomy of the data frame data structure of Pandas. Well, my dear students, once again, our data frame is a 2D labeled data structure. Note the column labels. In this case, these are strings: name, age, address, cell, and blood group. We can have integer indices over here as well. As far as the row indices are concerned, they are numbers or integers, 0, 1, 2, 3, 4, so on. So over here the axis 0 grows, and from left to right this axis 1 grows. As I have already said that since this is a 2D data structure, so we have two axes, axis 0 and axis 1. And on the intersection of each axis we have, of course, the data value. This is quite similar to an SQL table, and remember these columns can be of different data types. For example, this column over here, name, is of string data type, while this column, age, over here is of integer data type. Well, to create a data frame, we use the Pandas Dataframe method, to which we can pass 4 arguments and none is required. The first argument is the data, and that can of course be a 2D NumPy array, that can be a dictionary of Python list, that can be a dictionary of Pandas series, which we will see today. And of course you can create a data frame from a file in CSV format, Excel format, a JSON or HTML file, or maybe it can be a database table as well. Okay, and this index is actually the row indices. These are the indices which are provided via this argument. If you provide them, it's okay. If you don't, by default they will be 0, 1, 2, 3, 4 and so on. As far as this column attribute is concerned, this columns attribute represent the column indices. If you provide them, it's okay. If you don't provide them, the default will be 0, 1, 2, 3, 4 and so on. And finally, this is the data type. If you want to force the data type of the entire data frame, you can mention it. Let's understand this practically by running some piece of codes. Okay, so an empty data frame, there is no need to create an empty data frame. However, if you want to start from a very scratch and want to later on add things inside this data frame, you can do that. Normally, we create a data frame from a 2D NumPy array. Over here, I've used the randint method of the random module of NumPy to generate a NumPy array of size 6 rows and 5 columns. And I have assigned that NumPy array, that 2D NumPy array, to the data argument of the data frame method of pandas. So over here I have printed both the NumPy array as well and the data frame as well. Well, my dear students, note that in both the cases over here inside a NumPy 2D array, we don't have specific indices along the rows or the columns, but over here you can see the column indices 0, 1, 2, 3, 4 as well as the row indices 0, 1, 2, 3, 4, 5. We have not passed any index information to the data frame method, so the default indices has been assigned to this data frame. In majority of the cases, we keep the row indices to the default, that is 0, 1, 2, 3, 4, 5. However, we do mention some meaningful indices for the columns as the column names. Let's see, we have a code for that as well. So if you want to assign column labels to your data frame, you use the columns argument of the data frame method and you pass a list of columns of your own choice. You see, this time we have a better looking data frame having appropriate columns. They may be meaningful, but right now we have the random data. And similarly, if you want to have these row indices of your own choice, you can use the index argument to the data frame method. So over here, I'm just generating once again from the same 2D NumPy array, and this time I am assigning the row indices. Let me run this, and you see this time I have assigned the row indices and the column indices are default this time. And of course, we can assign them both. So we can assign both the index argument as well as the column arguments, appropriate list containing the row indices as well as the column indices or labels. Remember, this row indices and labels are interchangeably used. Normally, I prefer this term label whenever we have strings, and I prefer using the term index when we have numbers or integers for the integers. Okay, so that makes sense. Moreover, my dear students, once you have created a data frame, if you want to change these indices later on, you can do that by assigning it to the index and the columns attribute of the data frame object. So this data frame object df has an attribute index, and if we assign a list of indices to this, it will change the row labels. Let's see, we have done this as well. So we have generated once again a data frame having default row indices as well as the column indices. I have created two lists, one for the row labels and the other for the column labels. I have assigned column labels list to the columns attribute of the data frame and the row label list to the index attribute of the data frame. And this will do the job. I hope this makes sense. These indices are very important to understand as far as the data frames are concerned. That's why I'm spending a bit of more time on these. Okay, the way we can create a data frame from a 2D NumPy array, we can create a data frame from a dictionary of Python list as well. See, this is a dictionary, people. We have the key name, and with the key name we have a list of persons. We have the key age, and for the age we have the list of their ages, and then we have addresses, cell phone and blood group. I think we have seen this in the previous session as well. So this is a dictionary in which we have the keys, and with the keys we have a Python list. So let's use this dictionary now, this people dictionary now, to create a data frame. And we pass this dictionary to the data argument of the data frame method. Let's see that. Great. You see, I have not provided any index, a row index, nor I have provided the column index. However, the column indices has been taken from the keys of this dictionary: name, age, address, cell, and blood group. They have become the column labels, while the row indices have been set to the default, that is 0, 1, 2, 3, 4, and so on. And of course, if you want to change, you can always change that. And if I want to change, let's suppose I want to change these numeric indices to some meaningful labels. I have created this list row labels, and I have assigned it to the index attribute of this data frame. And remember, the name of the data frame this time is a bit meaningful, df underscore people. Let me run the code of this cell, and great. So this makes it more meaningful. These are the roll numbers, these are the attributes, and this is the data. Great. Oh well, finally let me tell you how we can create our data frame from our Dictionary of Pandas series. My dear friends, if you are not clear about series, please do watch our previous session. So this is a dictionary, DACT. This is the key of that dictionary, and the value of the dictionary is now, this time it is a Pandas series. And I have created a Pandas series from a Python list by passing a Python list to the series method of Pandas. So this has generated a series having names. This has generated a series having ages, and this has generated a series having addresses. And finally, I have passed the dictionary object to the data frame. I have passed the dictionary object to the data attribute. You can pass that as well to make it a non-positional argument. So this is the data frame that we have generated from our Dictionary of Pandas series. Okay, so I think this makes sense. The keys once again have become the column labels, and these row labels are set to default, that is 0, 1, and 2. We can of course assign the row indices by passing a list over here to the data frame, and we can of course set it as I have shown above by setting the index attribute of this data frame. Okay, let's see this. My dear students, over here once again I am creating a data frame from a dictionary, and this time I am passing the data argument to the series method as well as the index. I am creating index of my own choice, and if you note that 1, 2, 3, and 4, we have 4 data values and we have 4 corresponding indices A, B, C, D. In this series, the age, we have 1, 2, 3, and 4 values, out of which one is the NAN, and of course I have the 4 corresponding indices. For the address series, I have 1, 2, 3, and 4 values, out of which one is an empty string, and I have 4 corresponding indices. One more point that I want you to note that all the indices are same: A, B, C, D, A, B, C, D, and A, B, C, D. So let me run this, and you see a data frame has been generated having the keys of the dictionary as column names, and this time the row indices are A, B, C, D. And do note that we have an empty string for the address of this Hadid. This is the empty string corresponding to Hadid, and we have an NaN value for the age of Mujahid. So we have an NaN value, the third argument, related to Mujahid. Good. Okay, now a question arises that what if these indices, what I have mentioned over here, are different in these three series, what will happen in that case? Let's see this example. Over here, my dear students, in this code, you see we have once again the name series, and it has 4 values and the indices are A, B, C, D. It's okay, seems fine. For the age, we have this series, but the indices are 4 but a bit different. We have A, then X, then Y, and then D. We do not have B and C over here, and similarly we do not have X and Y indices over here. The third series, that is the address series, it has 3 values and having these 3 indices A, D, and X. So the point to be noted is that we have different number of values in each of these 3 series, and we have different indices in each of these 3 series. Now let's see what happens once we use this dictionary, such dictionary, to create a data frame. Okay, note that the resulting data frame has 6 rows. This series has 4 values, this series has 4 values, and this series has 3 values. But this data frame has 6 values. Okay, let me try to describe this. For this series, the name series, we have A, B, C, D. We have 4 values, Arif, Farid, Mujahid, and Maaz. A, B, C, D, we have Arif, Farid, Mujahid, and Maaz. And for these 4 indices, we have a value 50 corresponding to this A, so that 50 is here. We have a value corresponding to D, that is 18, so we have 18 over here. We do not have values corresponding to this index B and C, so you can see under the age column we have 2 NANs. Similarly, for if you see the address series, we have 3 values over here: Lahore, an empty string, and Karachi, and they correspond to A, D, and X. So in all the 3 series, we have a value corresponding to index A. So for index A, we have all the 3 values. For the index corresponding to this B, we have a value for B over here, but we do not have a value for B in the age and the address series. So for B, we have NAN for age and address series. Similarly, for C, we do not have a corresponding value in these 2, so we have NAN. For D, we have values in name and age series as well as for the address series. So for D, we have all the 3 values, but over here you can see the empty string. Of course, this is the empty string. And let's see about X now. This X index does not have a corresponding value in series of name. So over here we have an NAN. However, this X has a corresponding value for the address series. Therefore, we have a Karachi over here. And for this Y, note this Y is only there in this age series. And even over here, it has an NAN value. So this NAN in the age is because of that. And since this Y index is not there in the name and the address series, therefore naturally we have the NANs over here. My dear students, this is very important because in the later part of the courses we need to identify the null values, the NAN values, empty strings, outliers, and so on, and we need to join different data frames. They may have different indices, the row indices, they may have different columns. So you need to understand the concept of these indices very clearly before moving ahead. So if you are clear about this, it's okay. If not, please rewind this part of the movie and watch it again. And I'm moving ahead. Okay, let me talk about some attributes of Pandas data frame, and for that I have created a Pandas data frame as shown over here. This is the Pandas data frame. You see having row indices which are strings ms01, ms02, and so on. The column indices which are again string, name, age, address, and this is the data. Okay, so let's check out first of all the shape attribute. My dear students, the shape attribute of any data frame returns a tuple having two values. The first value represents the number of rows, the second value represents the number of columns. So we have 1, 2, 3, 4, 5, 6, 6 rows, the data rows. This row is not inclusive. Remember, the column labels are not added inside the shape. And similarly, as far as the columns are concerned, we have 1, 2, 3, 4, and 5. 5 columns. This column, this is the index. This is not inclusive. So that is why its shape is 6, 5. Then we have the dimensions, and of course, unlike series which have a dimension of 1, a data frame has a dimension of 2. And the size attribute returns the number of elements. The number of elements 1, 2, 3, 4, 5. 5 elements in a row. 1, 2, 3, 4, 5, 6. 6 rows. 6, 5 the 30. So we have 30 over here. My dear students, if you want to access the row indices, you can use the index attribute, which will return a list of the row indices as well as the type of the index. And if you want to access the column indices or the column labels, you use the column attribute of the data frame. And of course, you can get the values, which will be returned as a 2D NumPy array. And if you want to access or know about the data types of all the different columns, so it tells you that this name is of object type, this age is of int 64, and so on. And finally, the non-NA values can be get using the count method. This is the count method of the data frame, showing you the non-NA values. And the bonus part is the info method. This is a very good method. Whenever you come across a data frame for the first time, you run either the info method or maybe the describe method on that. And this info method, as you can see, it prints out information about the data frame, including the row indices. It tells you that there are 6 entries in the row indices starting from MS01 to MS06. It tells you the names of the columns over here: name, age, address, cell, and blood group. It tells you the non-null count of each column. It is saying that name is having 6 non-null values. So right now, none of the column contains any null value. And similarly, it tells you about the data type of all the columns. So, and finally, it tells you about the memory usage as well. Whenever you want to know about the memory usage of your data frame, you should use this info function. And this tells you that it is using around 288 plus bytes. Great. Right, my dear students, that is all for today's session. We will inshallah continue our journey to learn Python programming for data scientists in our next session. I hope today's session was informative for you all. If you have liked it, please subscribe my YouTube channel and share it with your friends. I wish you all the best, happy learning, and Allah Hafiz.